Jupiter, the undisputed king of our solar system, a colossus so vast it could swallow 1,300 Earths whole and still hunger for more. For centuries, we believed nothing could dwarf this giant. We were wrong, dead wrong. 1,200 light years away, something exists that shatters everything we thought we knew about planetary physics. A world so impossibly large, so catastrophically unstable that astronomers initially dismissed the data as a mistake. They ran the numbers again and again because what they found shouldn't be possible. This is a story of a planet that's committing suicide right before our eyes. Let me take you back to Earth for just a moment. Our home stretches 6,000 kilometers from core to surface. Vast oceans, towering mountains, an atmosphere thin enough to see through. We are small, fragile, and compared to what's coming, we're practically invisible. Now look at Jupiter, 11 times Earth's diameter. No ground to stand on, just endless clouds of ammonia and methane swirling in perpetual chaos. The Great Red Spot alone, a storm that's been raging for 400 years, could devour our entire planet 3 times over. Jupiter is a monster, the benchmark against which all gas giants are measured. But there's something out there that makes Jupiter look like a pebble. Its name is HAT P67b, and it's a nightmare wrapped in a mystery. When astronomers discovered this thing in 2017, they thought their instruments were broken. The readings were insane. HAT P67b measures 2.1 times Jupiter's radius, over 150,000 kilometers wide. Imagine a sphere so enormous that if you placed it where our sun sits, its outer edges would nearly touch Mars. That's not a planet, that's almost a star. It exists in the impossible space between planet and star, too massive to be normal, too diffuse to sustain itself, too close to its sun to survive. Its mere existence forces us to rewrite planetary formation theory. This world almost certainly formed far from its star, in the cold outer reaches where gas giants are supposed to live. Then, something catastrophic happened. Migration, gravitational chaos. It spiraled inward, drawn into a death embrace with its own sun. And now, we watch it burn. HATP 67b proves that in the universe, size isn't power. Size can be vulnerability. This planet grew so large it became fragile, a cosmic soap bubble drifting too close to the flame. It challenges our assumptions about what planets can be, how they behave, where the boundaries of planetary science truly lie. Out there in the constellation Hercules, a world 23 times the volume of Earth is dissolving into starlight, shining even as it disappears, magnificent even as it dies. The universe doesn't run out of ways to shock us. There are still worlds that defy everything we think we know. HATP 67b is one of them. A giant, a ghost, a warning written in evaporating hydrogen across the cosmos. And somewhere out there, there might be something even stranger waiting to be found. But here's where reality fractures completely. Despite being more than twice Jupiter's size, HAT P67b weighs less than a third of what Jupiter does, 0.34 Jupiter masses to be exact. It's a balloon pretending to be a world. Scientists have a technical term for this cosmic absurdity: a puffy planet. If you could somehow find an ocean large enough, this titanic sphere would float like a beach ball. Let that sink in. The largest planet ever discovered by radius would bob on water. How is this possible? How can something so colossal be so impossibly light? The answer lies in where this doomed world calls home, and it's worse than you can imagine. HAT P67b orbits an F-type star called HAT P67, a furnace 12 times brighter than our sun and nearly 3 times larger. But the true horror isn't the star itself, it's the distance, or rather, the lack of it. This planet screams around its sun at just 0.065 astronomical units, 10 million kilometers. That's 6 times closer than Mercury hugs our sun. 6 times. At that proximity, a year lasts 4.8 days. Think about that. Less than a work week. You could celebrate your birthday, go on vacation, and return home all in the same orbital period. The temperature? 1900 Kelvin. That's 1630 degrees Celsius. Hot enough to liquefy steel, to vaporize rock, to turn reality itself into a plasma nightmare. And this is where HAT P67b dies its slow, spectacular death. The star's radiation doesn't just heat the planet, it supercharges it. Every second, stellar energy slams into HAT P67b's atmosphere with the force of billions of nuclear detonations. The gas expands violently. Hydrogen and helium atoms rip apart, electrons torn away in a frenzy of ionization. The planet inflates like a balloon held too close to a blowtorch. Scientists have a technical term for this cosmic absurdity: a puffy planet. If you could somehow find an ocean large enough, this titanic sphere would float like a beach ball. But inflation is just the beginning of this world's apocalypse, because HAT P67b isn't just expanding, it's evaporating. Every single second, 10 million tons of atmosphere bleed into the void. 10 million tons. That escaping gas forms a colossal cloud around the planet, a tail of dying matter stretching 6 times Jupiter's diameter into space. Like a comet, like a ghost. This isn't a planet anymore. It's a slow-motion explosion frozen across cosmic time. Imagine standing on what passes for a surface if one could exist. Winds scream past at supersonic speeds. The sky above glows white-hot with escaping hydrogen. The star overhead dominates half the visible sky, an unbearable inferno that never sets, never dims, never stops its relentless assault. You'd last perhaps a fraction of a second before molecular annihilation. This is a world lighter than Saturn, yet wider than anything we've ever found. A sphere of gas, so tenuous, it defies the very definition of planet, and every moment it gets smaller, lighter, closer to non-existence. In a few 100 million years, maybe less, HAT P67b will be gone, completely consumed by its own star or stripped down to a rocky core no larger than Earth. A giant so magnificent it guaranteed its own destruction simply by existing. But why does this matter? Why should we care about a doomed planet over 1,000 light-years away? Because HAT P67b breaks the rules.